Welcome to the organic lab here at Wheaton College. Today we're going to look at how we take an infrared spectrum of an organic liquid. IR spectroscopy, or simply IR, is a term that we use for the technique of determining functional groups in a molecule. Functional groups like ethers, alcohols, ketones, aldehydes, carboxylic acids, amines, that sort of thing. And we have at our disposal here a Perkin-Elmer infrared spectrophotometer. This is really a great instrument, and it is very easy to take an infrared spectrum of an organic liquid. Now, what I say for an organic liquid is going to also obtain in most respects for an organic solid. There are a couple of interesting and important things that we have to do with a solid in order to determine the infrared spectrum of it. But what I say about a liquid is going to largely carry over to that of a solid, okay? So the first thing we have to do is to turn on the instrument. And we do that by means of turning on the computer that's behind this screen here. And we're going to come to this screen first. And we're going to, since this is at Wheaton College, we're going to click on Wheaton College. And we're going to then come to this screen. Now this screen has an icon pretty much in the middle of the screen, and we're going to click on that. It's going to say spectrum. And click on that. And that should, let's see. There, okay. And we come to this, and it's going to ask you a couple of questions, and you're going to say, yes, I'm the administrator, okay. And no, I'm not going to use the active IR assistant. Okay, and then it's going to come to the screen, which is going to record our infrared spectrum. Now, over in this window here, it will say ready. You cannot take an infrared spectrum if it doesn't say ready. All right? Okay, here's our screen, and there's some icons here at the top which we're going to use for giving us an infrared spectrum. The first one that we have to take is the scan of what we call the background. Now, we have this disk over here, and it's got in the middle of it a little bit of diamond material in it, and we have to take the background of it, which will be subtracted then from all of the infrared spectra that we take. So we go to scan, like that. We come to this particular window. And then over here in the upper right, we have an icon that it looks like, to me it always looks like an eye with an eyebrow. And if you land on it, it says background. So we're going to click that. We're going to come to this particular window and then hit scan. Now, it's going to take 4 pulses of the infrared spectrometer. You can see what the background looks like here. It's quite intense, actually. And you're going to go through 4 scans. Don't do anything. Let it proceed through 4 scans. And then it's going to come to this particular window. And now we're going to apply the benzaldehyde. I chose benzaldehyde because it is interesting. It has a benzene ring, it has an aldehyde, carbon-oxygen double bond, and it has some other interesting features about it. And I'm going to take my pipette here. I'm going to put just 1 drop right on that diamond in the center. Okay. So now we have the background. And I've typed in here already benzaldehyde, and that's going to identify the infrared spectrum that we get from this when we print it out. So once again, we're going to pulse this, but now instead of taking background, we're going to do start. So it says warning, duplicate file name. Yes, that's fine with me. And then scan. Just like with the background, it's going to have 4 pulses, and you'll see them accumulating here. And you can see right here the spectrum now of benzaldehyde. And Usually takes, at most a minute. All right. It says to overwrite. Yeah, we're going to overwrite this. That's fine. And so there's a spectrum of benzaldehyde. Didn't take too long, did it? And now we're going to prepare it for printing. First thing we're going to do is we're going to expand the x-axis so that it goes from left to right in the extreme. And we do this with opt view. And there you go. You can see that. Not only does it expand in this direction, but also in the y direction as well. All right, so now we want to know where these peaks are. It's important to know where they are. And so we're going to then click the peaks, and you can see that we have this set for a threshold where even small peaks like this one here at 3064 wave numbers is going to have a number associated with it. And so all of the important peaks now have numbers associated with them, and we can use this to identify benzaldehyde. All right, so what do we want to do? Well, we want to preserve this, right? So we're going to now print it. Bring this cursor over to the print icon, and you can tell that it's going to be printing because the ready data button will be blinking on and off. And in a few seconds, we should have the benzaldehyde infrared spectrum recorded for us. And you can use this, you can put this in your notebook, you can append this to your laboratory report, if you so wish. And here it comes. Okay. You can see the spectrum here of benzaldehyde relative to what you saw on the screen. Okay, now we're not finished, of course. We have to clean off the disk, and we have some Kim wipes here and some acetone in a squirt bottle, and what we're going to do is to clean off the patent. Now, if you're next in line to take an infrared spectrum, and the person before you has cleaned off, or should have cleaned off, the disk here, make sure that the acetone evaporates, because if you don't, you're going to get partially the spectrum of acetone, and you don't want that, obviously. So make sure that that's clean. Now, we're very fortunate to have a computer that gets us onto the internet, and there is a program which I encourage the students to use. It is simply called SDBS, and we can actually get this program through Google. Okay. Just type SDBS in there, SDBS, enter. And okay, this typing SDBS brings us directly to this particular window. And you can see it has all different types of criteria for looking up the spectra of your compounds. There are all kinds of spectra that you can obtain here, like the mass spectrum, the C13 NMR, the proton NMR, electron spin resonance, Raman spectroscopy, IR spectroscopy. All these are available for many of the compounds in this database. But all we need to put here for now is the name of the compound, and it's benzaldehyde. So let's go. Type in benzaldehyde, enter. Okay, and then here we have a whole list of compounds, one of which is benzaldehyde. There are others that are related to it, but here's benzaldehyde right on top, and wherever you see a Y, that means that there is that type of spectrum available. So for benzaldehyde, we have a mass spectrum, a C13 NMR, a proton NMR, an infrared spectrum, a Raman spectrum, and an ESR, or electron spin resonance spectrum. And so we're just going to click on IR, and here we have the infrared spectrum. Now, there are two types of infrared spectra that are available to us. In this case, we have what's called a carbon tetrachloride solution. We don't want that one. We want the one above it, the liquid film. So we click on that, and this is what we're going to compare our infrared spectrum that we just took with the published spectrum, which we have right here. And you can check and see that just about every peak, even little tiny ones, are represented on this particular published spectrum that gives us assuredness that that, in fact, is the infrared spectrum of benzaldehyde that we just took on our infrared spectrometer. Okay. Now, there are a couple of things that you should note about this. Let's say this peak at 1703, it says 4. Now, what does that mean? Well, I have a very large peak at 1698.84. Okay. That is the 1703 peak. We say the two numbers aren't the same. It is true that all infrared spectra on whatever instrument you take are going to be off by maybe 1, 2, 3, 5 wave numbers. That's unfortunate, but it's okay because it tells us that this is the most intense peak. How do I know that? Well, if you go over to the transmittance on the y-axis, you can see that it's all the way down to about, between 0 and 10 here, so that's about 4. So that's what the 4 means. It's the percent transmittance. And that, of course, is very much identifying that this is that particular peak. It's off by a little bit, but that's okay. We've identified it. And everything else is represented from this spectrum on what we've just taken. So we say we have benzaldehyde.